Hi everyone, and welcome to the fourth video in the Weather Unlocked video series. This video we're going to be going over weather patterns and how meteorologists can look at them to determine what type of weather we can potentially expect. Now, if you remember from the previous two videos, we learned about upper air launches as well as skew-T soundings. And we learned that as the radio song gets carried up into the atmosphere, it's collecting and calculating data that gets plotted onto the skew-T sounding. And from that sounding, we can then determine what the atmosphere is like, and we can also determine what type of weather we can potentially expect at that location. Now, that is very valuable. However, it only tells us what's happening in the atmosphere at that one location. So in order to get a bigger idea of the atmosphere as a whole, we're going to need to use radiosonde data from all of these upper air launch sites in order to help produce what's called a constant pressure chart. And here's an example of what a constant pressure chart looks like. So we're going to be taking a look into constant pressure charts on the next slide, as well as high versus low pressure, troughs versus ridges, and basic waves and blocking patterns. Now, we typically don't think about air being heavy. However, it's actually very heavy. We just don't notice it because we're pretty used to it. But not all areas have the same air pressure. Some areas actually have more pressure than their surroundings, and others have lower pressure than their surroundings. And this is where high and low pressure comes into play. Now, with high pressure, air typically moves clockwise around the center of the high, and it also moves away from the high pressure, or it diverges away from the center of the high. Now, when you have more pressure than the surrounding air, that leads to the air constantly being pushed away from the center of the high towards lower pressure. Now, with lower pressure, the air is going to move counterclockwise, and it's going to converge towards the center of that low pressure. So you can see that the air moves away from high pressure and towards low pressure. Now, when you have high pressure, air normally subsides or it sinks. Now, when the air sinks, it needs someplace to go. And since it can't go down into the Earth's surface, it has to move away from the center of the high. It has to show divergence. Now, when we have high pressure, we typically have clear skies, calm conditions, and dry weather. Now, on the opposite end, with low pressure, since the air is converging towards the center of the low pressure, that air again needs somewhere to go. Now, since it can't go into the Earth's surface, it then begins to rise. And typically when we have rising air, that can lead to cloudy skies and windy conditions and wet weather. So that is high versus low pressure and what to typically expect with the weather. Now, looking at constant pressure charts. Now, if you look at the image to the right, each of these charts shows areas of constant pressure. Now, the altitude that a particular pressure value occurs is going to vary, and that's going to be because of the different air densities. We'll take a look at that in a second. Now, this is where ISO heights come into play. ISO heights are lines of equal height. They're also known as contours. So if you look on the image to the right, you're going to see a bunch of lines plotted on these constant pressure charts. And those are the ISO heights, and they're representing the altitude that that particular pressure is occurring at. So looking at these constant pressure charts and the ISO heights, we can get a 3D representation of what the atmosphere looks like. Now, going back to the air density, so the height of any pressure level is going to be determined by the density of the air below it. So typically, when your air temperature decreases, the air density is going to increase. So when we have cooler air, the air is more dense, and that's going to lead to lower heights. On the opposite end, when we have warmer air, the air is going to be less dense, so that leads to higher heights. And that's where troughs and ridges come into play. Now, a trough is when we have that cold, more dense air, and that's going to lead to areas of lower heights. And ridges are areas of higher heights where we have the warmer, less dense air. So here's a constant pressure chart, and you can see the ISO heights are plotted. Now, looking at this chart, you can tell where the lower heights versus the higher heights are. So the trough is going to be indicated by the brown dashed line, and the ridges are indicated by the brown zigzag lines. And depending on the position and orientation of these troughs and ridges, we can tell what type of weather could potentially occur. Now, typically ahead of a trough, we can expect unsettled or deteriorating weather. And ahead of a ridge, we can expect fair or improving weather. Now this video is taken from NASA's Goddard Space Flight Center, and it shows the troughs and ridges as indicated by the jet stream. So typically the winds flowing from a ridge towards a trough are going to be decreasing in height, and the winds flowing from a trough towards a ridge are increasing in height. And so you can tell that this clearly mimics that wave pattern. So let's take a look at the basic wave patterns. Now when we have an open wave, we have no closed circulation associated with the waves, and it's very progressive, so it's going to move from west to east. Now this is the most common weather pattern that we typically see, and you can see that we have unsettled weather ahead of the trough and fair weather ahead of the ridge. Now typically a trough won't be straight up and down. There's going to be some tilt to it relative to the poles, and this is where the positively tilted trough comes into play. This is going to extend from the lowest pressure northeast to southwest in the northern hemisphere, and it typically produces the least amount of severe weather. Now on the opposite end, we have a negatively tilted trough. These usually begin as a positive tilted trough, but then they get their shape distorted to a negative orientation, which is northwest to southeast. Typically, these do produce the most severe weather because there's very strong southerly surface winds, as well as a lot of instability and wind shear that can lead to severe thunderstorms. Now, we also have what's known as a cutoff low. This is very persistent low pressure areas that have become isolated or cut off from the main airflows. Typically, these move very slow and they can drift for days. And the typical weather that we see with cutoff lows is very prolonged, unsettled weather, especially for the eastern half of the low. And then lastly, we have what's known as zonal flow. This is where the airflow is parallel to the latitude lines. And typically, if we have any surface level storm systems, they're going to move fairly fast from west to east in the zonal flow. And we're not going to see much north to south movement. Now, typically north of the zonal flow or poleward, we're going to see cooler or cold weather, and south of it or equatorward, we're going to see mild or warm weather. And usually at either side of the zonal flow, we have a positive and a negative tilted trough. So those are the basic wave patterns. So now let's take a look at blocking patterns. Now, blocking patterns occur when centers of high and low pressure set up over a region in a way that prevents other weather systems from moving through. And this can remain in place for several days, leading to long spans of persistent weather. So the first blocking pattern is the blocking high. Now, a blocking high typically occurs during the summer, and it's responsible for major heat waves. Now, when you have high pressure aloft, that's going to cause the air to sink, which warms the air in the lower atmosphere and traps the heat at the surface. And usually we're going to see clear skies with blocking highs. Now, an omega block gets its name because the pattern kind of looks like the Greek letter omega. And this is where you have two cutoff lows with a blocking high sandwiched between them. Now, because of their size, they usually are very persistent and can lead to either flooding or drought conditions depending on your location. And with the lows, we usually see cooler temperatures and precipitation. And then with the highs, we can typically see warm or clear weather conditions. And the last blocking pattern is the Rex block. Now with the Rex blocks, we have high pressure poleward of a low pressure system. And this typically remains nearly stationary until one of those systems changes its intensity, unbalancing the pattern. Now with the low pressure system, we can typically expect unsettled and stormy weather, and with the high pressure system, we can expect mild and dry conditions. Now when you have very strong persistent Rex blocks, this can cause flooding near the lows and short-term droughts under the high pressure systems. So this is how basic wave patterns and blocking patterns can help us show what type of weather to expect at certain locations. So that concludes this video on weather patterns, so stay tuned for future videos in the Weather Unlocked series.